Good morning, my dear students. Now I'm going to start. That is video number 4. In this video, I'm going to discuss the retarding plates. The word itself indicates that retard means reduce or decrease. That is, supposing the vehicle is moving, you are applying the force. When you are applying the brake here, the moment you apply the brake, that what happens? The acceleration is what? Decreases here. Then finally the vehicle becomes to what? Rest. Retardation means decrease, that is. But in this way of optics or polarization chapter, what is the retardation means? As you know that in the double refracting crystal, I covered in the video number 2 and 3, where that is what? This is the double refracting crystal. Double refracting crystal. Now, this is the incident ray. This is the unpolarized light. Unpolarized light. When it is incident on it, as you know that there are two beams are coming out, and another one is what? This is the A ray. This is called as an what? E ray, and this is called as an what? O ray. Here the vibrations are one kind. It is like this, parallel to the optic axis. This is the optic axis. Here the vibrations in the O ray are what? Perpendicular to this here optic axis. This here. So that you are getting how many images are formed here? Two images are formed. One is due to what? E ray, and another one is due to what? O ray. And all these things I covered in the previous video. That is. Here, these plates, it creates the path difference between the E ray and O ray. It creates the what? Either path difference or is what? Phase difference between the E ray and O ray, and such plates are called as what? Retarding plates. What is retarding plates? A plates such that which produces the path difference between the E ray and O ray. How it produces? The speed of the one ray is more and the speed of the one ray is what? Less here. That is nothing but what? Retardation is. Now, these retarding plates are classified into two types. Retarding plates are classified into what? Two types. One is a quarter wave plate. It is quarter wave plate. And another one is a off wave plate. The word itself indicates that quarter means 1/4. For example, in this is the one complete sine wave. This is the sine wave. From here to here, this is what? Lambda, that is. And here, this is this distance, I will call it as a what? Lambda by what? 2. And off of it, here it is off of this complete wave. This is lambda by 2. And off of it, this becomes what? Lambda by what? 4 here. Path difference is how much it is? Lambda by 4 here. And another thing is here, path difference equal to lambda by what? 4 here. And what about phase difference? You see, this is one complete wave here. For one complete wave, it is 0. This is what? 90. This is 180. This is 270. This is what? 360 degree. One complete wave is 360 degree. Off means how much it is? Here it is 360 degree. This point and this point. Off means this. This is 0 degree and this is what? 180 degree. Again off of it, this becomes what? 90 degree. That is called as phase difference. Phase difference equal to, it is 90 degree. 90 is nothing but what? In radian, we are writing what? Pi by 2. That is. This much of path difference should be produced between the what? Between the ordinary ray and extraordinary ray here. I will not say that whether the ordinary ray is what? The faster or extraordinary ray is faster. That I will not say. Again, that will be decided by the what? What kind of crystal you are selecting. Are you selecting the positive crystal or positive that is what? Positive, the double refracting crystal, or negative double refracting crystal and all that. Okay, fine. Here, now let us come to the definition of what? Coulter wave plane. How it is produced. This is produced such that here, a plate of a doubly refracting crystal, I will write the definition. A plate of a doubly refracting crystal, a doubly refracting crystal, okay, whose refracting faces are, this is one face and this is what? Another face. Whose refracting faces are cut. How they are cutting? Parallel to the optic axis. Parallel to the optic. This surface and this surface is cut. It is parallel to the optic axis, and thickness is such that, and the thickness of the crystal T, and the thickness T is such as to produce a path difference. A path difference equal to how much it is? Lambda by what? Path difference equal to lambda by 4, and produce a path difference. I will call this about delta x equal to what? Lambda by 4. Phase difference delta phi equal to pi by what? 2. This is the exact definition of the what? Coulter wave plate. What is retarding plate here? Retarding plate means these plates are nothing but double refracting crystals, and these crystals are cut in such a fashion that is a path difference should be produced between the what? Ordinary ray and extraordinary ray. One ray will be travels faster and another ray will be travels what? With a lesser speed and all that. Here, how this crystal is designed here, how these plates are designed here, that this face and this face, assume that these are the two refracting faces. These faces are cut. How it is cut? Parallel to the what? Optic axis. I told you that optic axis is imaginary line. It is a direction, and it is passing through the blunt corner. Okay, whose cut parallel to the optic axis, and the thickness T. What is the thickness of that? To produce what? A path difference equal. It is delta x nothing but path difference, and delta phi is nothing but what? Phase difference equal to what? Pi by 2 and all that. And even ask question, what is the use of the what? Coulter wave plate here? Then why are you doing all this circus here in designing the Coulter wave plate and all that? The Coulter wave plates are used to produce the what? Circularly polarized light, and also what? Elliptically polarized light here. To produce the what? Circularly polarized light, and also what? Elliptically polarized light. Go through that, but previous derivation in the video 3, it is here elliptical polarization, circular polarization, and what? Plane polarized are discussed from the mathematical equation I discussed here. There I think you will come across with the path difference, phase difference equal to what? 90 degree and all that. Remember one thing, what is the use of the Coulter wave plate here? The Coulter wave plates are used for what? To produce the what? Circularly polarized light, and also what? Elliptically polarized light here. Next, 2-3 steps I have to write. First, here phase difference equal to, first I will write phase difference equal to how much it is? 5 by 2. Why it is 90? I told you that is for one complete wave it is how much it is? 360. From here to here, 360 means how much? 2 pi. Up to this, it is what? The phase difference is what? Half of it. And for this, 1/4, it becomes what? Pi by 2. And all that. Next, path difference equal to, what is this? Here, Completely one wave is what? Lambda. Up to this is what? How much it is? Lambda by what? 2. But only the half of it, it becomes what it is? Lambda by what? 4 here. And also, we know one more thing here, that is a path difference equal to path difference. It is difference equal to refractive index, that is thickness into NO difference of NE. That is the most general equation. What is NO? Refractive index of the what? Ore. What is NE? Refractive index of the what? Emergent ray. Here I have written the difference. Why I have written? I don't know which is greater here. That is. For the positive crystal it is different, and negative crystal it is also what? Different. Slightly I am deviating from this discussion. Here, go through my previous video where for positive crystal, that is NO is less than what? NE. For negative crystal, exactly opposite. It is NE is NO is what? NO is greater than what? NE. That's why I have written what? General equation I have written here. Now, this is equation number 1, this is equation number 2, this is equation number 3. This is also path difference. This also what? Path difference. Here, these two equations I will equating equation 2 and equation 3. Then can I write T into NO difference NE equal to what? Lambda by 4. Therefore, T equal to lambda divided by 4 into NO difference of what? NE. This is the most general equation, students. The problems are very simple in this chapter here. You should know wavelength. You should know refractive index of what? Ordinary ray. You should know the refractive index of what? Extraordinary ray. From that knowledge, I can get the what? That is I can calculate the thickness of the crystal here. How much you have to cut that crystal now? That is more important. It all depends upon, that is pi by 2 and lambda by what? 4. And also depending upon the what? The refractive index for the O ray and E ray. This is about the quarter wave plate. What is the use of the quarter wave plate here? In order to what? Develop the what? In order to produce the what? Circularly polarized light and also what? Elliptically polarized light. This quarter wave plates are what? Used here. Remember this. This is very important. Many places I am using. Positive crystal means NO. Just you have to bite it. NO is less than what? NA. Or negative crystal, NO is greater than what? NE. Okay. Student. Now next plate is what? Off wave plate here. Off wave plate. First I will define it. A plate of a doubly refracting crystal. It is a doubly refracting. As a calcite crystal is there, tourmaline crystal is there, whatever you take, quartz crystal is there. A plate of a doubly refracting crystal whose refracting faces are cut parallel. This is one refracting face and this is another refracting face. Are cut. How it is cut here? This is one optic axis. It is cut parallel to the direction of the what? Optic axis. Are cut. How it is cut? Parallel to the direction of the optic axis. And the thickness T is such as to produce. What to produce? Path difference equal to lambda by 2. And phase difference equal to pi. How it is? I tell you now. This is one complete wave, student. This is one complete wave. From here to here, path difference is represented by what? Lambda. Now it is off wave. The wave It is off wavelength. The word itself indicates that it is off of it. From here to here, the distance is what it is, lambda by what? 2. That's why I have written what? Path difference equal to what? Lambda by 2. What about phase difference? See, here, this point and this point, what is this is 0 degree. This is what? 90 degree. It is 90 degree. This is what? 180 degree. This is what? 270 degree. This is what? 360. From here to here it is 360 degree. Off means up to this. This will become what? Phase difference between this point and this point is how much it is? 180 degree. 180 degree means what it is? 1. This is the what? The phase difference is produced between the what? Between the O ray and E ray, that is. Next. Here. This is equal to, this is equation number 1 and this is equation number 2. And also we know that in geometrical optics and all that, path difference equal to, we can write in this fashion. Path difference equal to thickness NO difference NE. It is difference symbol. Just it is a symbol for difference. You have to subtract the smaller value from the greater number and all. What is NO? Refractive index of ordinary. What is NE? Refractive index of what? Extraordinary ray. This is equation number 3. Here LHS, this is also path. This is also path difference. This is also what? Path. I am considering this equation. I am considering this equation. Now I will equate this and this. Equation 1 and 3 I will equate here. So that can I write T into NO difference NE equal to what? Lambda by 2. Therefore, T equal to lambda divided by 2 into NO difference of what? NE, student. I think you understood this. Then you are going to ask question, what is the use of the off-wave plate? Very important use of the off-wave plate is to produce the plane polarized light here. To produce the plane polarized light. But in the previous case, in the quarter wave plate, that plates are used to produce the what? Elliptically polarized light and also what? Circularly polarized light. And one more interesting thing, of course, is not required. If the angle of incidence is theta degree in off-wave plate, I am talking about off-wave plate. If the angle of incidence is theta degree with respect to optic axis, then the angle of emergence is what? 2 theta. If the angle of incidence with respect to optic axis, suppose if it is 15 degree, then what about the angle of emergence is what? Double this, that is 30 degree and all that. Why it is and all that, don't worry, bother. But where they are using, this off-wave plates are using to produce the what? Plane polarized light here. Sometimes you may get 4 more question, discuss the off-wave plate and quarter wave plate. What is retarding plates? And also they ask a question, what are retarding plates? The retarding plates are the one which produces the what? The path difference and phase difference between the what? Ordinary and extraordinary ray. It is general definition. Again, under that we classified into what? 2 types. One is off wave and another one is what? Quarter wave and all that. In the quarter wave, we are writing lambda by 4 comes. That is the only difference. The rest of the things is what? Same and all that. Okay. Next I will discuss the detection and production and detection of the plane polarized light, circularly polarized light, and also what? Elliptically polarized light. Students, now I am going to solve the problems on desktop. Problems on the retarding plates. Whenever you want to solve the problems in any particular chapter, first list out all the formulas which comes under that category. Just now discussed T equal to lambda by 4, NO difference of NE, it is corresponding to what? Quarter wave plate. And another one is T equal to lambda by 2, NO difference of NE, it is for the what? Off wave plate. Think it in the problem whether has he given the quarter wave plate or off wave plate. And this is the equation you are using many times in the interference chapter also, in diffraction also, where the phase difference delta phi is nothing but, I think we understand or not, this is phase difference it is. This is equal to 2 pi by lambda into what? Path difference. Path difference is, some books they will write only delta they will write, but some books they will write what? Delta x they will write. X stands for what? Distance. That's why I have written here. Okay. Now, first I will solve the very easiest problems I will solve. First, go through the question. Find the least thickness of a Coulter wave plate. Already defined. It is what kind of plate here? Coulter wave. What do we find here? Thickness. For which NO is given, NE is given, and lambda is given here. First, you write given parameters. What are the given parameters? Next, to be calculate. Here, we know that what are the given parameters? NO equal to, we know that, 1.5442. NE equal to 1.5533. And thickness equal to what? 5 into what? 10 to the power of minus 7 meter. Suppose sometimes they give in terms of Armstrong. Suppose 5000 Armstrong. How you are writing? Equal to 5000 into 10 to the power of minus 10 meter. 1 Armstrong equal to 10 to the power of what? Minus 10 meter. Like this, many problems comes in the interference chapter and also what? Diffraction chapter. Here 3 zeros are there. Then it becomes 5 into 10 to the power of what? Minus 7 meter. Of course, in this problem he has given directly in meter, is no problem. Now, what to be calculated here? I want to calculate thickness equal to what? Which formula you are using? It is Coulter wave plate. Now, may I use this equation? T equal to lambda divided by 4 NO difference of what? NE, I am writing. Substitute the value of lambda equal to 5 into 10 to the power of minus 7, 4 into difference. You have to subtract smaller value from the greater value. Here 1.5533, 1.54421, it is 9, 0, 0, it is 0. It means it is 0.00, it is 0.0091. Substitute all these values and then calculate. This turns to be what? It is near about T equal to 2.75 into 10 to the power of minus 5 meter. This is the thickness of the Coulter wave plate. Students, the problems on this chapter are very, very easy, that is. There are only 2-3 sets of problems becomes on this chapter. One is on the Brewster's law and another one is problems on the what? Retarding plates and all that. But so far, still I have not solved the problems on the Brewster's law. I have not solved. I will solve it in the next video and all that. This is one sample problem. Okay, one more problem I will solve it. Okay, it is problem number 2. This is problem number 2. Okay. Find the least thickness of a Coulter wave plate. It is also Coulter wave plate has given. For which NO equal to 1.586, NE equal to 1.592 and lambda equal to 5460 Armstrong, where plate is made up of mica sheet. Mica is also double refracting crystal. It is a uniaxial double refracting crystal. Okay. Now, what are the given? What to be calculated here? Thickness. What kind of plate it is? It is Coulter wave plate. Again, you write all the given parameters. You write it here. Given parameters. Given parameters. To be calculated. To be calculated. Here you see given parameters NO equal to 1.586, NE equal to 1.592. That is. From this we can find whether it is a positive crystal or negative crystal and all that. Here NO is, which is greater here? Here Ne is greater. Ne is greater. Yeah, remember. Okay, don't bother about this. And to be calculated, thickness equal to what? I told you how to identify. For the positive crystal, always, for positive crystal, velocity of ordinary ray is greater than what? Velocity of extraordinary ray. Then n equal to c by what? V. If velocity is more, it is n is what? Less. That means NO is less than NE. NO is less than what? NE. That means refractive index of extraordinary ray is more than the refractive index of what? Ordinary ray. That means why I am saying this point is always while solving the problems only we can understand the physics more part of it. We can love the physics. We can understand the concepts more clearly. Here you see NE is 1.592, NO is 1.586. Then which is greater here? Ne is greater. Then certainly it is a positive crystal. Then what kind of sheet has taken here? Mica. That means mica sheet comes under the what? Positively double refracting crystal. But whereas calcite is a negative crystal. That is. Calcite is a negative crystal, but mica is a what? Positive crystal and all. Here, now I want to calculate the thickness. What is the formula for this quarter wave plate? T equal to lambda divided by 4 NO difference of what? Ne. And substitute all these values are substituted. This one. T equal to lambda equal to, what is the value of lambda he has given? Equal to 5460 into 10 to the power of minus 10 meter I am writing. Because answer is in what? Armstrong is there. So that it is 5460 into 10 to the power of minus 10 divided by 4 into. Difference is asking. Difference of NO difference area. Here 1. I'll write here 1.592 minus 1.586. 0, 0, 0, 0. That means 0.006. 0.006. You substitute all these values and then calculate. It will be translates into 2.275 into 10 to the power of minus 5 meter. I would hope that using calculator you will do rest of the calculations, will do it. Okay. These are all one set of problems in the retarding plates here. Actually, it is not worth for the 4-mark question. Here, I will solve one more question. Some typical question I will solve it. There you are making use of what? This formula also I can make use of it. Okay. Now let us discuss question number 3, students. Read the question. Calculate the path difference and phase difference. Slightly problem is different. I supposed to be calculate path difference and phase difference between what? O ray and E ray. Between O ray and E ray. For which lambda, wavelength of the light used, is 5000 angstrom and plate thickness T equal to 30 micrometer. It is a micrometer. That's micrometer. Micrometer. If NO equal to 1.5512 and NE equal to 1.5422. Look into this problem here. Which is greater here? NO is greater. The refractive index of ordinary ray is greater than the refractive index of what? Extraordinary ray. Analyze the data. In the previous problem, it is NE is greater than what? NO. Just go through the previous problem. Problem number 2. There in the previous problem, I said that it is a negative, positive crystal, I think. Okay. 1. For negative crystal, what is the situation? For the negative crystal, VO is less than what? VE, that is for the negative crystal. And we know the formula, N equal to C by V. If V is less, then because ordinary velocity is what? Less. N is what? More. NO is greater than what? NE. This is the crust. NO greater than NE. Here you see, NO is greater than what? NE. So that this must be a what? Negative crystal. This must be a negative crystal. Probably negative crystal is calcite is a negative crystal, that is. Okay. Of course, it's not required, but to understand the physics, one should know all these things, which is positive and which is negative and all that. Okay. Now I will write it. What are the given parameters? You know that. The given parameters are what? You know that thickness equal to, that is given parameters. Given parameters. Next is to be calculated. What are that? T equal, lambda equal to how much? 5000. Can I write like this? 5 into 10 to the power minus 7 meter. Directly I am writing. Because 3 zeros cancels. Then T equal to what? 30 into 10 to the power of minus 6 meter. NO equal to how much? 1.5512. NE equal to how much it is? 1.5412. That is okay. What to be calculated here? Delta phi equal to what? And delta x equal to what? I supposed to be calculate path difference and phase difference. Okay. Recall my student, one more formula I will write. In the previous derivation, quarter wave plate and half wave plate. Path difference equal to I have written T into NO difference of what? N. This formula I used in the half wave plate and also what? Quarter wave plate here. Here you say, I want to calculate the path difference and also what? Phase. This is called as phase difference. This is called as what? Path difference. Take it. What to be calculated? I want, this is the equation connects the relationship with the path difference and phase difference. But I know that delta x I can calculate. That is delta x equal to T into NO difference of what? A. First calculate. Path difference, I will write delta x equal to T into NO difference of what? A. What is the difference here? It is difference 1.5512, 1.5412, 0, 0, 1, 0.3. It is, this turns to be 0.0100. What is this? It is in meter only. Thickness is a meter. Because this is meter, of course, refractive index has no unit and all that. You know the path difference. Then think it, phase difference. Which equation is suitable here? I think probably this equation. Now, delta phi equal to, what is delta phi? Equal to 2 pi by lambda into what? Delta x. Substitute this equal to 2 pi divided by lambda value, we know that 5 into 10 to the power minus 7 into, it is how much? 0.0100. To calculate all these things. Substituting all these values, we can calculate what? This comes around radian, it comes. The angle in the SI unit of angle is radian. Don't write degree and all that. This is turns to be 3.39 what radian is. 3.39 radian. I think you understood this. This formula we are using in some of the problems. Path difference equal to T into NO difference if any, and also what? Delta phi equal to 2 pi by lambda into what? Delta x and all that. I hope that you understood this. Okay, I will solve one more problem. I will solve it by making use of this formula and also what? This formula. Really the physics is involved in solving the problem number 3. In problem 1 and 2, just nothing in it. That is just simply calculations. That's nothing in it. Students, now look at this problem 4 is very interesting problem. It is. A plain polarized light is incident on a quarter wave plate. Okay, it is a quarter wave plate. Okay. Find the thickness of the plate. That means T to be calculated. Find the thickness of the plate. To calculate thickness, you have to calculate T equal to what? T equal to what? Which produces a phase difference between O ray and E ray. Of course, I have not written here. What is the phase difference here? 60 degree. And has given NO value is given, NE has given, and lambda has given. Okay, fine. How to do this problem? Here, phase difference, path difference immediately should comes in our mind. This equation you have to use here. Here, what is delta phi? Delta phi equal to 2 pi by lambda into what? Delta x. What is delta x? Delta x nothing but path difference. What is the formula for the path difference here? T into NO difference NE. Can I write like this? Delta phi equal to 2 pi by lambda into T into NO difference of NE. Which is greater here? NE is greater. I will write NE minus of NO. I will write because in the given data NE is what? Greater. Okay. Now the question arises in your mind. Of course, T to be calculated. Lambda is known here. NE is now. NO is now. But how to calculate delta phi, that is? Here you say phase difference is 60 degree. 60 degree means, I will tell you that is. Suppose that is the one way, please, conceptual question it is. This is comes in diffraction and polarization also. This particle and this particle, particle 1 and particle 2. What is the phase difference between them is, this is 0 degree, this is what? 360 degree. What is the phase difference between the particle 1 and 2? It is how much it is? 2 pi. What is the phase difference between the particle this and this? It is how much it is? Pi. But here he has given the particle, I don't know where the particle is. It may be here, that is. This and this. The phase difference how much has given here? 60 degree has given. This 60 degree always should not write 60 degree directly, but is SI unit is degree is not this one, radian is the unit for. So that cannot write pi by 3, that is pi by 3 equal to, how much it is pi by 3 equal to what? Pi by 3, it is 180 divided by 3 equal to how much? 60 degree. Can I write pi by 3? Now, I think you understood this. What is the phase difference here? Pi divided by what? 3 equal to 2 pi by lambda into bracket T into NE minus of what? NO. Okay. Now I will delete it. Here is it. Okay. You see, what is NE minus NO? NE 1.553, 1.544. It is 0, 0, 0, 0. It is 0.009. This is the difference. Which factor get cancelled? This pi is what? Get cancels. Then can I write lambda divided by 6? Lambda here, 2 here. 3 into 2, 6. Equal to T into, what is this difference? NE minus NE equal to 0.00 what? 9 I write. You know the value of lambda, you know that. So that using this, I will modify it. Lambda, sorry, therefore, T equal to, what I can write? Lambda. This factor I will bring in denominator into 0.009 I can get 0.009. And you know the value of lambda, you know that. What is the value of lambda is there? 5400 into 10 to the power minus 9 divided by 6 into 0.009. You substitute all these values, and then calculate the thickness. It turns out to be, it is 10 micrometer, that is, because 6 nines are, that is what, 6 nines are 54, 9 cancels here, so that only one term will be left here, so that 100 something, it turns to be what, 10 micrometer. This is a very interesting problem. Suppose if it is given 30 degree, then what to write here? 30 means pi by 6 you have to write, because pi nothing but what, 180 divided by 6 equal to what, 30 degree. Okay, now I will stop the discussion on this. Today I solved the problems on the half wave plate, quarter wave plate, and also derived the equation for the what, half wave plate and quarter wave plate here. Suppose the question is like this. What is the thickness you are getting? 10 micrometer. What are the first three thickness required? If the question is like this, it is the least one then. 10 micrometer is the least one. Next thickness is what? 20 micrometer. Next thickness is what? 30 micrometer. Like this you have to go on do it, that is. Okay, I don't want to create a confusion. I will stop my discussion at this point. In next video, you can just observe that I will discuss the production and detection of the plane polarized light, circularly polarized light, and also what? Elliptically polarized light. It is important from the point of examination. So normally they will ask for the circularly polarized light and also what? Elliptically polarized light. There is no derivation, nothing here. Just like what it is, purely it is a theory here. Ramayana or Mahabharata. Listen my talk or watch this video very carefully, watch it here. Then once you watch very carefully, easily you can reproduce it in what? Examination. Thank you, one and all.